All right, guys, as you know that computer networking is a very important topic. So I will summarize this for your understanding because it will impact and it will help you to understand the networking deeply as well. Okay, guys, so you understand now the computer networking is a very important chapter. So this document, I'm going to summarize it. Well, this document will serve as a detailed guide to the computer networking, breaking down complex concepts into easy to understand and explanations. It starts by defining a computer network as a system that connects devices like computers, photos, and servers to share data and resources. These connections can be wired using Ethernet cable or wireless via Wi-Fi or cellular network. The key components that make networking possible includes the router, which direct data traffic between the network, and switches, which connect devices within a network efficiently. Protocols like TCP, IP act as the rules that govern how data is transmitted, ensuring reliable connection. This explains different type of network, each serving a specific purpose. A local area network, that is LAN, connects devices in a small area like home or office, while a wide area network, that is WAN, links distant locations such as branch offices in different cities. Metropolitan Area Network, that is MAN, covers larger areas like cities, and specialized network like Strong Area Network, that is SAN, provide high-speed access to shared storage devices. The document also introduces ISCSI, a protocol that allows computer to use remote storage as if it were directly attached, simplifying the data management. Networking hardware, as we discussed in depth, it is comparing older technologies like hub with a modern switch. Hubs are outdated because they broadcast data to all connected devices, leading to inefficiencies and collisions. In contrast, switches intelligently route the data only to the intended receipt, improving speed and reducing the congestion. The document also covers the different types of switches, which include unmanaged switches for simple steps and managed switches for advanced control, such as conferring the VLAN and monitoring the traffic. The section on communication media explains the cable and connector used in networking. Copper cables like Cat5e and Cat6 are common for Ethernet connections, with each category supporting different speeds and distances. Fiber optic cable, including single mode and multi-mode fiber, offer high speed, long distance data transmission, while coaxial cables are used for TV and older internet connections. The documents detailed connectors like RJ45 for Ethernet and SCLC for fiber optics, ensuring proper connectivity. I've also explained about the wireless networking with a focus on Wi-Fi standard, that is 802.11a/b/g/n, and their frequency bands like 2.4 GHz for range and 5 GHz for speed. Highlights the importance of proper installation, including choosing the right channel and minimizing interference from other devices. Bluetooth, RFID, and NFC are also introduced as wireless technologies for short-range communication, enabling features like contactless payment and device pairing. Now, as we have already discussed about the network topologies in this chapter, such as star, bus, ring, mesh, and hybrid topologies are explained, each with its own advantage and drawbacks. For example, a star topology is easy to manage but relies on a central hub. while a mesh topology offers redundancy but is more complex to set up. The document then transitions to network addressing covering IPv4 and IPv6. IPv4 uses 32-bit address like 192.168.1.1, while IPv6 employs 128-bit address to accommodate more devices. Public and private IPs are distinguished, with private IPs used for internal network and public IP for internet communications. The role of key protocol like TCP, UDP are clarified. TCP ensures reliable ordered data delivery, making it ideal for web browsing and email, while UDP provides faster connectionless transmission suitable for video streaming and gaming. The document also lists well-known ports for services like HTTP, where it uses port 8080, HTTPS, which uses port 443, and DNS, that uses port 53, helping readers understand how data is routed to correct applications. Now, as discussed about the servers, they play a crucial role in networks, and the document explains their various functions. File and print servers manage shared resources, web servers host website, and mail server handle email traffic. Directory servers, like those who using LDAP, store user information for authentication, while proxy servers act as intermediaries controlling the access and improving the security. Security means like firewall and spam gateways are emphasized, while firewall filtering traffic based on rules and spam gateways blocking the unwanted emails. Unified threat management, and we discussed the UTM systems combine the multiple security feature into a different solution, therefore simplifying the protection. Now, we have already discussed about the load balancers. I will just summarize it once again for you guys. Load balancers are introduced as tools to distribute network traffic across multiple servers, preventing the overload and ensuring the smooth performance. The document also touches a legacy system which are outdated but still in use, posing the security risk due to the lack of updates. Internet of Things, that is IoT devices like smart speakers, thermostats, are highlighted for their ability to connect and automate everyday tasks. Finally, the document provides troubleshooting tips for common network issues for wired connection. It advises checking cables, ports, and configurations, while for wireless problems, it suggests verifying signal strength and minimize interference steps to resolve limited connectivity, such as checking DHCP settings and DNS configuration, also outlined. This document is a thorough yet accessible resource on computer networking, covering everything from basic concept to advanced technologies and some troubleshooting. It equips readers with knowledge to understand, configure, and maintain network efficiently, making it a valuable reference for both beginners and experienced professionals. The clear explanations and practical examples ensure that even complex topics are easy to grasp, providing a solid foundation in network principle. Modern computer networks form an invisible circulatory system that powers global digital communication, enabling everything from simple file transfer to real-time international video conference, as it functions like a complex interplay of hardware, software, and protocol working in harmony to create a reliable data pathway. Unlike traditional telephone systems that establish dedicated circuit, modern packet switch network break information into discrete units that travel independently before reassembling at their destination, allowing for unprecedented efficiency and fault tolerance. The physical infrastructure of network represents a marvel of engineering evolution where humble copper wire coexist with cutting-edge fiber optics capable of transmitting data at near light speed. These physical layers conceal sophisticated error correction mechanisms that automatically compensate for signal degradation, electromagnetic interference, and other environmental factors. Wired technologies add another dimension, transforming the very air around us to data carrying medium through specifically modulated radio waves that can penetrate wall yet remain secure through advanced encryption protocols. Network architecture follows carefully designed hierarchical model that mirror organizational structure in the business world. Just as employees having departments, teams, and individual employees network segment into autonomous system, subnets, and individual hosts. This structure enables both micro-level traffic optimization and macro-level routing efficiency across global internet backbones. The Border Gateway Protocol, that is BGP, serves as the Internet diplomatic corps, constantly negotiating pathways between the autonomous system with a complexity that rivals international relations. Data transmission embodies a delicate balance between reliability and speed represented by TCP/UDP, where TCP provides guaranteed delivery through acknowledgement handshake resembling certified mails. UDP offers the network equivalent of broadcast podcast faster but without delivering the confirmation. Modern applications intelligently combine these approaches using the UDP for real-time video while reserving TCP for a critical control signal. As we already learned about the DNS over here, the DNS, that is the domain name system, functions as the Internet's cognitive mapping system, translating human-friendly names into machine-readable access through a distributed global database that updates near real time. This system resilience comes from the decentralized nature, which cached entries and fallback mechanisms, ensuring continuity even when individual component fails. BNS security extensions have transformed this system from a simple directory to a verified authentication mechanism that underpins the Internet trust models. Network security has evolved into a multi-layer defense strategy that mirrors medieval castle for fictions. Firewall serves as gatekeepers, intrusion detection systems add watchtowers, and encryption act as a protective armor for data in transit. The rise of zero-trust architectures acknowledge that threats can be originate from within network perimeters also, leading to a continuous authentication system that verify users and devices at every access attempt rather than just an initial entry. Now, the virtualization technology have scattered traditional physical network, allowing software-defined networks to create a logical topologies independent of underlying the hardware. VLAN partition networks with software rather than physical rewiring, while virtual private networks, that is VPN, extend secure tunnel across the public infrastructure. Cloud networking takes this further with entire data center topologies existing as mutable software constructs that can be reconfigured on demand. The IoT of things, that is Internet of Things, represent network's most dramatic expansion, connecting billions of previously dumped devices into the intelligent ecosystem. Thus, networks face unique challenges balancing limited device resources with security reasons, often employing novel protocols like MQTT that prioritize the efficiency over traditional networking features. Smart cities demonstrate this evolution where network censored optimized traffic flows, utilities, and public services in real time. Now, the network troubleshooting has developed into a scientific discipline combining protocols analysis, statistical modeling, and machine learning. Modern diagnostic tools and pinpoint microscopic timing variations that indicate failing components or detect intrusion patterns hidden within the normal traffic flows. AI now assists in predictive maintenance, identifying potential failure before they impact users based on subtle performance deviations. The networking field faces ongoing challenges in scaling to meet the exponential demand growth while maintaining the security and privacy. Innovations in compression algorithm, more efficient protocols, and smarter routing algorithm help bridge the gap. Network professions are now require knowledge on spanning electrical engineering, software development, cybersecurity, and data science. Certifications have proliferated to validate this diverse skill set through the rapid pace of change demands continuing the learning. This field has matured from technically specialty into a strategic business function that directly impacts the organizational competitiveness and operational resilience. So that's all for this topic on networking. I have summarized the things for you. It will help you to understand the networking of computers into depth and will also help you to understand the concept of the networking. Thank you very much for this, understanding and this topic. And we will see you on the next topic. Till then, have a great day. Bye.